Hi, I'm Jessica, and welcome to our crash course on solving algebraic problems. This crash course has 2 videos, so this is the first in our series, and it addresses secondary 2 students. But if you're in secondary 3 or beyond, then it could be a really good refresher for you. So in our video, we're going to look at how to solve algebraic problems using the 5 following steps, because we always pretty much do the same thing when we're solving this kind of problem. The first thing we do is define the variables. Second is write the equation. Third, solve the equation. Fourth, verify the solution. And finally, the 5th step, give a complete answer. The first example we're going to do is actually going to take you through all 5 steps. But then after that, every other example, we're really just going to concentrate on these first 2 because those are most important. If we can't get the equation right, then we're going to have a hard time getting the right answer. So let's go. So for our first problem, we're going to look at average temperature. We've got right here, on March 20th, temperatures were recorded in 4 major Canadian cities. In Quebec City, the temperature was 3 degrees lower than in Montreal. In Toronto, it was 5 degrees warmer than in Montreal. Lastly, in Vancouver, the temperature was twice Toronto's. Given that the mean temperature in these 4 cities was 3 degrees Celsius, what was the temperature in Montreal that day? Well, the first thing we have to do is define the variables. And to do this, we've got 4 cities and they're all talking about temperature. So what we've really got to do is get specific here and refer to the temperature in these 4 cities. It's not good enough to just say, X is whatever city. We need to say what aspect of the city we're talking about. So since it's temperature in all 4 of them, then I'm just going to write it once, temperature in, and then I list my cities, Montreal, Quebec City, Toronto, Vancouver. One of these 4 cities is going to be represented by our variable. Often we choose X. Really, it can be any letter we choose, any letter we want, but X is used more often. It's what I'm going to use here. And we're looking for the city that every other city's temperature is being compared to. So if I just check my problem here, the first part of it says in Quebec City, the temperature was 3 degrees lower than in Montreal. So here I'm having the temperature in Quebec City being compared to the temperature in Montreal. The second part says, in Toronto, it was 5 degrees warmer than in Montreal. So once again, Toronto is being compared to Montreal. This is a good indicator that my variable is going to be the temperature in Montreal. So I'm just going to write my X right there next to Montreal. There we go. So now I'm ready to set up for the other ones. Let's look at Quebec City. It says, in Quebec City, the temperature was 3 degrees lower than in Montreal. So if I take Montreal's temperature and I subtract 3 degrees. That is what I'm going to use to represent Quebec City's temperature. Now, I got to be careful here because a common mistake that students make is to reverse those. So to say 3 minus X. But a subtraction is not reversible like that. So I won't get the same answer. X minus 3 is not the same thing as 3 minus X. I need to be really careful with that. This isn't an addition that we're talking about. So just think about it if I actually, for a moment, replaced numbers in here. If I were to say 5 minus 3, that would give me 2 as my answer. But if I said 2 minus 5, that's going to give me negative 3. So it's not at all the same answer. Be careful of that. All right. Next up is Toronto. And if I read what it says about Toronto, it says that in Toronto, it was 5 degrees warmer than Montreal. So this time, I've got to take Montreal's temperature, which is my X, and I've got to add 5 degrees to that. And that is what's going to represent Toronto's temperature. Lastly, I have Vancouver, and it says that in Vancouver, the temperature was twice Toronto's. So this time, I've got to look at what it says about Toronto and multiply that by 2. So I'm going to take, for Vancouver, it's going to be 2, and I need to make sure that I get brackets around that entire statement that represents Toronto. So in other words, 2, and then in brackets, my X plus 5, because I'm going to have to distribute that 2 over what's inside the brackets. And I need to make sure that everything is getting multiplied because it's the entire Toronto temperature that gets multiplied by 2, not just the X or the 5. All right. So that means I can also simplify this. I talked about distributing it. So now I'm going to distribute it to show you how that's done. 2 is going to multiply by X to give me 2X. And 2 multiplies by 5 to give me plus 10. So in Vancouver, the simplified algebraic expression to represent its temperature would be 2X plus 10. And now we're ready to write our equation. So this is the fun part. Now, the equation we can use, usually it's the last part of our problem that we use to guide us into writing our equation, or through writing our equation, sorry. It's often the last statement. In our case, that is the last statement that we're going to use, but sometimes it's embedded a little higher in the problem. So you just want to make sure that you scan through really quick to ensure that you get the right part of the problem to write your equation with. In our case, we have given that the mean temperature in these 4 cities was 3 degrees Celsius. What was the temperature in Montreal that day? So the mean is the same thing as the average. So to calculate the average or the mean, I've got to look at the sum of all the data and divide it by the number of data that I have. And in this case, the sum of all my data, well, they're not numbers, they're actually algebraic expressions. So I'm going to take each of these algebraic expressions and I'm going to add them together. And then I'm going to divide that by 4 because I have 4 different cities or 4 data values. And that, of course, equals to the left side here, which is the mean, and that is given in the problem. What that looks like is this right here. I have the mean 3, or the average 3, is equal to the x for for Montreal, the x for Montreal, the x minus 3 for Quebec City, the x plus 5 for Toronto, and the 2x plus 10 for Vancouver. So add those all up, and then I divide them by the 4 data values. And I get this simplified algebraic equation, which is 3 is equal to 5x plus 12 over 4. So I've taken the like terms. In other words, I've taken everything, all my x's, and I've added them together. X plus x for 3 x's plus another 2 x's to give a total of 5 x's. And then I took my constants, negative 3 plus 5 plus 10 to give me plus 12. And again, divide by 4. I am now ready to solve my equation. So the first thing I'm going to do to solve my equation, I want to get rid of this denominator here. So I have to get rid of the 4, and to do that, well, I've got to do the opposite of, in this case, I'm dividing by 4, so I've got to do the opposite of that. I'm going to multiply that entire side by 4. So I'm just going to put some brackets in here to show that everything is going to get multiplied by 4, just like that. And of course, if I've done that to one side of my equation, I've got to multiply by 4 on the other side of the equation. So I'm just going to show that on my 3 also. Here we go. So right now, my left side says 4 multiplied by 3, and my right side is everything in the brackets multiplied by 4. But everything in the brackets has that nice little division by 4. So if I'm multiplying and dividing by 4, or multiplying and dividing by the same number, I can cancel out that number. So my 4s are going to cancel, and I am left with this situation. 4 times 3 gives me 12. So on my left side, I have 12. 12 is equal to 5x plus 12. It's super important that you notice that the 4 is gone. Okay, that right side no longer has a 4. It got canceled out. All right, I'm ready to go the next step. I have to isolate that x. So I'm going to remove the 12 from the right side. So I'm going to just take it off there, but I also have to take it off over on the left side here. All right, and that is going to give me 0 is equal to 5x. My last step is to get rid of this 5 here. So since 5 is being multiplied by x, I've got to do the opposite of that. I've got to divide by 5. So I'm just going to divide by 5 over here. And I also have to divide my 0 by 5 over here. And my 5s are going to cancel out on, 5 cancels out on that right-hand side. And on the left-hand side, I'm left with the answer, which is x is equal to 0. So sometimes 0 can feel like a funny answer to get. We don't always get it. I mean, it's a number like any other, but it can feel a little bit strange, except if I think about the context of this problem, it's actually perfect because we can have 0 temperature. And that would make sense for Montreal in March. So to have 0 degrees in Montreal on March 20th is a logical thing. So it gives me confidence that my answer is correct. I do, however, need to verify that my answer is correct. And so to do this, I'm just going to make sure that I find the temperatures in each of the others, in each of the other cities, because I'm going to have to plug all of that data into my original equation and find out if the means match up. In other words, I'm going to find the sum of all my data, divide it by my 4 data values, and see if that gives me 3. So let's do that. I said that Montreal is equal to 0 degrees. That's the X value I found here. That means that in Quebec City, I have 0 minus 3 to give me negative 3 degrees. That also makes sense for Quebec City in March. In Toronto, that's 0 plus 5 to give me 5 degrees. That makes sense for Toronto in March. And lastly, I have 2 times 0 plus 10 to give me plus 10 degrees in Vancouver, which, lucky Vancouver, makes sense for March 20th. I'm going to put that into my mean equation here. So now instead of all these x's, I'm going to use the numbers. Montreal plus Quebec City plus Toronto plus Vancouver, all divided by 4. If I add up my numerator, this gives me 12, which I then divide by 4 to give me 3, which is exactly what I was hoping for. I just have my one last step, which is to complete my answer. And that includes just writing a little sentence. So my answer is that the temperature in Montreal was 0 degrees Celsius, which is exactly what I calculated. I'm super happy about that. I don't need to go any further because my question just asked me about Montreal. So I don't actually have to include any of the other cities in my completed answer and my sentence at the bottom. So I'm done. All right, so for our second problem, remember, from this point forward, I'm just doing the first 2 parts with you guys, and I'll leave you guys to do the last 3. So we only did the whole 5 steps in the first problem. Here we have candy issues. Leanne has half as many candies as her sister Anais, who has 4 less than her brother Justin. If combined they have 49 candies, how many candies does each sibling have? Well, the first thing we're going to do here is define the variables. But before I go any further, I have a question for you guys. True or false? In this problem, the variable x must be assigned to Leanne. If you answered false, you are correct. We can really assign it to any one of them, but you do want to pick one that's going to make life easy on you. So we try and avoid in algebra the divisions and anything that would require us to subtract. So if I take a look at how my problem is set up here, sometimes creating a diagram like this one here can help you organize your thoughts. And if we took, say, Anais for a moment, it says Leanne has half as many candies as her sister Anais. So if I put Anais, this number of candies, as my variable x, that would mean that Leanne's number of candies would have to be represented by x divided by 2, which is arguably a little awkward. If I try it the other way, I'm just going to erase this. And it says, well, Leanne has half as many candies as her sister Anais. So the opposite direction, if I put x as my number of candies, as the number of candies that Leanne has, then that means that Anais's number of candies is represented by 2x, which is a little easier to deal with. Now we're ready for Justin. So Justin has, so it says Anais, who has 4 less than her brother Justin. So representing 4 less than her brother Justin could actually also be said as, well, Justin has 4 more than Anais. So if I take Anais's number of candies, which we said was 2x, and I add 4 candies to that, then I have the algebraic expression representing Justin's number of candies. And I'm ready to continue on to writing my equation. Right? So when I'm writing my equation, sometimes it's helpful to write it all out in words. So this would look like the number of candies for Leanne plus the number of candies for Anais plus the number of candies for Justin equals 49, which represents the total number of candies. But this is pretty long. So we can shorten it to L plus A plus J is equal to 49. But that's not very helpful in terms of solving for our variable or answering our question here. So I'm going to go one step further, and instead of writing L, A, and J, I'm going to replace those with the algebraic expressions that we just generated. So that will give me x, which is Leanne's number of candies, plus 2x, or Anais's number of candies, plus 2x plus 4, which is Justin's number of candies, equals 49, which is the total number of candies. And we're done. At this point, you guys going forward, to finish this problem, just so you know, at the end of this, you should be getting that Leanne has 9 candies, Anais has 18 candies, and Justin has 22 candies. But this is as far as I'm taking you today. So for our third and final problem, we're going to talk about geometry. Geometry, when there's algebra in geometry problems all the time, and well, algebra is actually in a lot of different kinds of problems. So here we go. The height of a rectangular wall is 30 centimeters less than half its base. If the perimeter of the wall is 10.2 meters, what are its dimensions? So the first thing we're going to do is, of course, define the variables. And to do that, I'm going to sketch out a little rectangle to represent our situation. I would suggest you do the same. So when I see base here, I'm actually referring to the measure of the base. And when I say height, I'm talking about the measure of the height of this. Before I go any further, I have a question for you. So if the base is represented by the variable b, the height is which one of those statements? If you answered b, or b divided by 2 minus 30, then you were correct. So let's get that up here. The measure of our base then is going to be b. We're going to represent that with the letter b. And the height then, the measure of our height is going to be represented by b divided by 2 minus 30. Now you might be asking yourself, didn't she just tell me that we want to avoid divisions and subtractions? I also told you that you can use divisions and subtractions. They're just not often ones that make it easy to solve. So in this case, it's actually going to be easier to use a division, and you'll see why in a moment. So let's continue. I'm going to write my equation now. And we don't want to make the same mistake in writing our equation that many people do make, which is the common one of just accounting for 2 of the sides. So perimeter, remember, is the full distance around a shape. If I just say perimeter and I do b plus h, then I'm only accounting for 2 sides on my rectangle. And so it's not going to give me the perimeter. It doesn't give me all 4 sides of my rectangle. So I want to make sure that I double that. So if I have b plus h, or the base plus the height, then I've got to make sure that I multiply that by 2 to reflect all 4 sides of my rectangle. Now I'm ready to plug in my known values. So this is what I get. I get perimeter of 1020 is equal to 2 times, in brackets, b plus b divided by 2 minus 30. You might be wondering about that 1020. Now, remember, if we look at our problem, the perimeter was given to me as 10.2 meters. But over here, they talk about the dimensions of the height, and they refer to 30 centimeters. So I have 2 different units. I've got to get them all into the same units for my problem to work. And so I've converted my 10.2 meters into the equivalent centimeters, which is 1020 centimeters. 30 stays in centimeters, and we can go forward from here and get our right answer and get the correct answer. All right. So I'm going to simplify this, and you'll see in simplifying why it became convenient to use a division in this case, because that 2, of course, had to distribute over everything inside the brackets. So when I take 2 and I multiply it by b, that gave me my 2b. When I took 2 and I multiplied it by b over 2, it allowed me to cancel out the 2's, leaving me with b by itself. So it's a little easier to deal with. Then I have 2 and I multiply that by the negative 30 here to give me negative 60 in my problem. I can simplify it once more to collect these like terms here. So my b's are going to add together to give me 1020 is equal to 3b minus 60. I have a simplified equation that I can now move forward with. And I'm going to encourage you guys to do just that, but on your own. So going forward, if you get one of your dimensions as 360 centimeters, then you know you're on the right track. So that brings us to the end of the first video in our series of 2 videos on solving algebraic problems. So in this video, we looked at various different strategies for solving this kind of problem. And in the next video, we're going to increase the level of difficulty a little bit. So go take a little bit of a break. And when you're ready, come on back and watch that second video. You can also take a break and go and check out some of the associated problems with this video so that you can get a little extra practice. I'll see you next time.